Hello everyone, this is Umang Mamani here and welcome to another video of our 2 playlist. Today we will see a medium category problem that is shortest unsorted continuous subarray. The description says you are given an integer of array nums where you need to find continuous subarray that if only you sort this subarray in ascending order, the whole array will be sorted in ascending order. Now the subarray means a part of the array like 4, 8, 10, 9 or 6, 4, 8, 10, something like this, and it should be continuous. So you cannot have something like 2 6 and then 10 over here, or 4 8 and then 15 over here. So basically it should be continuous like all together. And if you sort this sub array in ascending order, basically the whole nums array should result in a sorted array. So in this example, if you sort 6 4 8 10 and 9, so basically its length is 5, the whole nums array will result in one complete sorted array, hence the output is 5. So as we know, once the array is sorted in ascending order, the smallest number is at the beginning and the largest number is at the end of the array. So let's say if we start from the beginning of the array to find the first element which is out of sorting order, that is, which is smaller than its previous element, and similarly from the end of the array to find the first element which is bigger than its previous element. So will the sorting of the subarray between these two numbers result in whole array getting sorted? Let us understand with this example. So if this is the nums array given to us, starting from the beginning of the array, the first number that is out of sorting order is at 2, as it is smaller than its previous element which is 3. Now starting from the end of the array, the first number out of sorting order is 0, as it is bigger than its previous element which is minus 1. So it will be 1, minus 1, 0, 2, 3, 7 and 10. Now as you can see, sorting the numbers between 3 and minus 1 will not sort the complete array. The problem here is that the smallest number of our subarray is minus 1, which dictates that we need to include more numbers from the beginning of the array to make the whole array sorted. We will have a similar problem if the maximum of the subarray is bigger than some elements at the end of the array. So this approach will not work if you only sort the subarray. Now let me show you one of the approach that you might come up during your interview. So let's say if this is your given unsorted array, what you might do is you might think in reverse. That is, for example, let me copy this array again and I will write its sorted version. So it will be minus 1, 0, 1, 2, 3, 7 and 10. Now this is the given input array and this is your final sorted array. Now to sort this, you will require n log n time. Now once this is sorted, you can compare the elements by using the for loop, and whenever you find the mismatch between the elements, you can set the pointer there indicating the start of the mismatch of the element, and similarly from the end you can start comparing the element and you can set a pointer where you find the mismatch. So now by keeping the track of the minimum index position for start pointer, let's say this is the start point over here, we found the mismatch, so it is at 0 position, and for the end we keep the track of the highest index position where we found the mismatch. So in this example it is over here. So you can see that at index 4 position we have the mismatch and at index 0 position we have the mismatch. So our length of the subarray will be 5. Now by using this approach you will able to complete the problem, but the time complexity and space complexity is not accepted. So in this video we will see how we can solve the problem using O of n time complexity and O of 1 space complexity. So now let us go through the code and understand the purpose of each step. First, we will start with our low and high pointer. Low will be at 0, that is at the start of the array, and high will be at the end of the array. Now from the beginning and end of the array, we will find the first elements that are out of the sorting order. So in this while loop, we will start with the condition that low should be less than the length of the array, and if the element at low is less than its next element, That means it is out of sorting order. For example, 3 and 2 over here. So we will place our low pointer at 3. So until then, we will do low plus plus. Now we should also check if low equals to nums of length. That means your low pointer has reached at the end and the array is already sorted. So in that case, we will simply return 0. Now similar to low pointer, we will also write the while loop for our high pointer. So for that, high is greater than 0 and element at high pointer is greater than or equal to its previous element. So we will do high minus minus. For example, in 0 and minus 1, we will place our high pointer at minus 1 position. Now after this while loop, we will initialize two variables that are min and max. For minimum, we have initialized using integer.max, and for max, we have initialized using integer.min. Now the subarray which we have found using low and high pointer, in that subarray, we will find our minimum and maximum element. So for that, we will use a while loop starting from I equals to low, going up to high pointer, and we will calculate our max and min pointer using math operator. Now let us understand the use of max and min. So if this is the subarray we had found earlier, using this max and min, we will extend the subarray such that from the left side, it will include all the numbers which are bigger than the minimum in the subarray. And similarly, from the right side, we will extend the subarray such that it will include any number which is smaller than the maximum that we found in our subarray. So to extend the subarray, we will write our two while loops. For low, while it is still greater than 0 and the previous number, if it is greater than minimum, we will extend our low pointer, and for the high pointer, while high is less than the length of the array and the next number, if it is less than the max that we found, then we will increment our high pointer as well. Now doing this, we ensure that we capture all those elements which were not included in our subarray earlier, but now with the help of this max and min variable, we ensure that all the elements which satisfies these conditions are included in our subarray. Now once this is done, we will simply return the length of our subarray, that is high minus low plus 1, because the array starts from 0. So let us run the code now, and it is accepted. Now before we submit, the time complexity over here is O of n and the space complexity is in constant space. So we will submit it. So guys, I hope you understood these two approaches, and if you have any queries, please let me know in the comment section and I'll be happy to answer you. Also, like, share and subscribe this channel to help me solve more problems for you. Thank you.